Hello and welcome. I'm going to tell you about finding the perpendicular bisector of a line segment. So, to find the perpendicular bisector of a line segment, I suppose first of all we need to think about what a line segment is and what it means for something to be perpendicular. So a line segment you can think of as part of a line. A line extends infinitely in both directions, but a line segment is just a piece of a line. So here we've got 2 points, and the part of the line that connects them is called a line segment. Now what we're going to do is find the perpendicular bisector of that line segment. Beautiful. Now, the perpendicular bisector of a line segment is a line that's perpendicular to the segment. So, what does that mean? Well, that means that it is at right angles to it. So, the angle that it makes when it intersects the line segment is 90 degrees. So, as you can see here, this grey line would be something that's perpendicular, but also this grey line is also perpendicular to the line segment, as is this one. And in fact there's infinitely many lines that we could find that are perpendicular to this line segment. So we need an extra condition for it to be unique, and that's that it must pass through the midpoint of the line segment. So a perpendicular bisector is a line that's perpendicular to the line segment and passes through the midpoint. So here we can see this red line is the contender that we're looking for. So we know how to find midpoints because we've done that in class. In previous classes we've looked at how to find the equation of a straight line. So we should have everything we need in order to make progress here. So let's just have a quick recap of finding the equation of a straight line, because we're going to use that quite a lot. Now remember we had those 2 points, so let's find the equation of that line segment between them. So let's imagine we've got these 2 points, x1 and y1 is the coordinate of the first point, and x2 and y2 is the coordinate of the second point. What's the equation of the line between them? Now you'll have seen this in a previous class, but let me just remind you, there are 2 things you need. You need the slope and you need the y-intercept. So the slope we usually denote with the letter m, and some of you will probably have learnt it as rise over run, which is a snappy little Americanism, I like it. Or the way it's drawn in Britain is just the difference between the y-coordinates and take that and divide it by the difference between the x-coordinates. So y2 minus y1 over x2 minus x1. And it doesn't matter if you do the first point first, so if you mix up the y2 and the y1, as long as you also mix up the x2 and the x1. So the other thing we need is this y-intercept, this b. Now, the equation of a straight line is y equals mx plus b. We need to know what the b is. Now, given that we know 2 points on the line, once we've worked out the slope, we can find b really easily. We just take one of the points and we plug it in. We know that every point on this line has an xy coordinate that satisfies this equation. So let's pick the first point. We substitute in the y value. We substitute in the x value. Now look at this. We know what m is, because it's just going to be a number. We know what y1 is. We know what x1 is. So now when you look at the blue equation, the only thing we don't know is b. And so we could just rearrange it to find out what b is. Then we'll know m and we'll know b, so we will know the equation. Let's look at an example. So here's some points. 2 points are 2, 3 and 7, 10, and there's the line segment connecting them. Let's work out the equation of the line for which this is a segment. We're going to need to know m, we're going to need to know b, and once we've got those two things, we'll put them in the equation of a straight line, which is y equals mx plus b. Okay, so remember the way we work out m, which is the slope, is we take the difference in the y coordinates and we divide it by the difference in the x coordinates. So we're going to do 10 minus 3 divided by, well, we've got to keep the order when we're doing the x's, so we chose the 10 first, so that means we have to choose its pair, which is 7 first, so 7 minus 2. It gives us 7 over 5, 7/5. So we can write that in and erase what was going on in our little thought bubble there. And now we know that y equals 7 over 5 times x plus b. So we just need to find out what b is. We have some points on the line. We know that every point on this line has to satisfy this equation. So we can plug in one of the points and then we'll find out what b is. So we know that when x is 2, y has to be 3. So let's plug in those values. So when y is 3, x is 2, so that means that 3 has to equal 7/5 times 2 plus b. And from this, the only thing that we don't know is b, and we can rearrange it to find out what b is. So let's have a look, right? When we multiply 7/5 by 2, we get 14 over 5. We bring that over to the other side and we get that b equals 3 minus 14/5. We can combine those terms when we get a common denominator, which would give us 15 over 5 for the first term minus 14 over 5 for the second term, so that gives us 1/5. So, look at that, we know what b is. Let's write it in. Now we know everything we need to know. Plug in the m, we plug in the b, and we've got the equation of a line. Beautiful. So we're going to be doing that a lot because we're going to be trying to find the equation of the perpendicular bisector. We're going to use the slope of the line segment to work out the slope of the bisector. We're going to use the fact that it passes through the midpoint to find out what b is, and then we'll end up with the equation. So let's just double check that everyone knows what perpendicular lines are. Okay, so if I've got this line here, then a line's perpendicular to it if it intersects it at 90 degrees. If it doesn't intersect it at 90 degrees, then it's not perpendicular. So these two lines are not perpendicular, the other two are. So you may recall this from previous classes, hopefully you do. If you don't, then consider this a fancy new fact. Two straight lines are perpendicular if the product of their slopes is -1. So that means if you're ever faced with two lines and someone asks you if they're perpendicular, find the slope of one, find the slope of the other, multiply them together and see if you get -1. If you do, those lines are perpendicular, and if you don't, then they are not. Let's look at a quick example. So here we've got two lines, y equals 3x plus 2 and y equals -x plus 1. The slope of the first one is 3, right? Because remember y equals mx plus b, and the m is the slope. And the slope of the second line is -1, right? Because y equals mx plus b, so b here is 1, which would mean m has to be -1, right? So that works out. Now what happens when we multiply those two things together? When we multiply the slope of the first line by the slope of the second line, we get -3, which is not equal to -1. So that means that these two lines are not perpendicular. What about another little example? Here we've got y is 1/3 times x plus 2 and y equals negative 3x minus 1. The slope of the first line is 1/3 and the slope of the second line is negative 3. So when we multiply these two together, we get negative 1. So they're perpendicular. So that means if we were to draw them, if we were to plot these two lines, then those two lines would meet at right angles. So, what are we doing here? We are trying to find the equation of the perpendicular bisector of a line segment. Now, here's our little line segment. It's between these 2 points. And there is the perpendicular bisector. How are we going to find its equation? Well, to find the equation, it's a straight line. So we need to know its slope and we need to know its y-intercept. But we remember that as long as we know the slope and a single point on the line, then we can work out what the y-intercept is, right? We can work out everything we need just from a single point on the line and its slope. So let's think about its slope first of all. Now we know that it's perpendicular to the line segment, so when we take the slope of the bisector and we multiply it by the slope of the line segment, we should get negative 1. Okay, now I know the slope of the bisector, right? It's the difference in the y values over the difference in the x values. Rise over run. So look at this. We've now got this little equation going. Now, if I multiply both sides through by x2 minus x1, and then divide both sides through by y2 minus y1, or you might like to think of this as cross-multiplying, what I'll end up with is that the slope of the bisector is equal to negative, and then in parentheses x2 minus x1 divided by y2 minus y1. Just take a moment to rearrange that in your head if you are unsure of what happened there. Now, I can distribute that negative that's outside the x2 minus x1 inside, and what I get is that nice little formula at the top. The slope of the bisector is x1 minus x2 over y2 minus y1. So let's erase all this, we don't need that anymore, we know what that slope is. The other thing we need to remember is a point on the bisector. If we've got a slope, when we have a point, then we can work everything else out. Now remember that the perpendicular bisector of this line segment passes through the midpoint, and we know the equation of the midpoint. It's nice and easy. We did this in previous classes, so it's just the average x value is the x coordinate and the average of the y values is the y coordinate. So now we know the slope, we have a point, so we just plug these things into y equals mx plus b, and in the usual way we can find the equation of the line. And then we're done. So let's do an example, because these things are much easier when you see them all worked out. So let's find the perpendicular bisector of the line segment between these 2 points, -3, -5, and 2, 4. Okay, so first of all I need to know what the slope of the line segment is. Once I know the slope of the line segment, then I can work out the slope of the bisector, because remember it's going to be the number that when you multiply it by the slope of the line segment gives you -1. So the slope of the line segment is this rise over run, right? So 4 minus -5, well that's going to give us 9, because the negative and the negative make the positive. And Let's divide that by 2 minus negative 3. So that gives us 5. So we've got 9 over 5 is the slope of the line segment. Now remember, the perpendicular bisector is perpendicular to that. So the slope of the bisector is a number, m, that when you multiply it by 9 over 5 gives you negative 1. That number is negative 5 over 9. Now let's double check that we really have found the slope of a line that's perpendicular to the line we started with. Multiply these two slopes together. Do we get negative 1? Yes, we do. So that's good. So we've got the slope of the bisector. Now, the point on the bisector is the midpoint, and the midpoint is just going to be the average of these two x values and the average of these two y values. So that's negative a half, negative a half. We've got the slope, we've got a point on the line, we are very nearly done. Because this point lies on the line, we know that it has to satisfy y equals mx plus b, where m is this negative 5 over 9. So let's plug in. Y is negative a half, x is negative a half. Plug those in. Notice that b is the only thing we don't know here. So let's tidy it up a little bit. So, right, here we're just doing some little calculations. Right, we know that negative a half is equal to minus 5 over 9 times negative a half plus b. So we can rearrange all that, and we eventually get that b equals negative 7 over 9. If you don't see it right away, pause the video, work it out on a little bit of scrap paper. So we have b is negative 7 over 9. And then we can plug these things in. Now y is equal to mx plus b. M is negative 5 over 9, b is negative 7 over 9. Now, you notice that there's a 1 over 9 in the first term, and there's a 1 over 9 factor in the second term. So we can factor out 1 over 9 in all the terms on the right hand side, and we can move it over to the other side by multiplying everything through by 9. If we do that, we end up with something that looks a little bit neater. So let's multiply both sides by 9. We get that 9y equals negative 5x minus 7. And that's it. That is the equation of the perpendicular bisector of the line segment between negative 3, negative 5 and 2, 4. Easy, right? Okay. Well, now it's your turn. So, I want you to find the equation of the perpendicular bisector of the line segment between these 2 points. Negative 1, 3, and 2, 2. So, just pause the video, try it, and then restart the video when you think you have the answer. Okay, so hopefully you worked it out, and I have my fingers crossed that you got the right answer. Right, we want to know the slope of the perpendicular bisector, so we need to know the slope of the line segment so we can work out what the slope of the line perpendicular to it will have. The slope of the line segment is negative a third, so that means that the slope of the line we're interested in, the slope of the perpendicular bisector, is going to be 3. Let's double check. When we multiply the slope of the perpendicular bisector by the slope of the line segment, we should get negative 1, and we do. Hooray! celebrate. Now, we need to find a point on the line. So we've got these, we know the midpoint is the average of the x values and the average of the y values. So that's easy to work out. That's going to be a half and 5/2. So yeah, we've got our slope, we've got a point on the line, we can work out what b is. Plug in these values. We know that every point on the line is an xy pair, where when the x value is plugged into the equation, the y value matches. So in this case, when x is a half, we'd better have that y equals 5/2. Let's plug that in. 5/2 equals 3 times a half plus b. b is the only thing we don't know here. So we can rearrange this to find b. Now of course, this involves some fractions, as we've been doing all along. Hopefully you're very, very happy manipulating fractions. So we rearrange it, we get b is 5/2 minus 3/2, that has a common denominator, so that's just 2/2, and that's equal to 1. So look at this, we know m and we know b, they're the only things we need to find the equation of the line. So hopefully you got that right, and now I would say if you understand everything that happened here, then you need to practice. So you need to find about 20 questions to do, and after 20 questions you will be a perpendicular bisector expert.